to Snark Chocolate, a show about cryptography products, where we break them down with rich flavors and sweet insights. I'm Queenie, and I'll be co-hosting this episode with Omer. Today, we're thrilled to be joined by Jules Drean, co-founder of Tinfoil, a full-stack platform offering verifiable privacy for cloud AI. Jules, it's great to have you on the show.
Hi, welcome everyone. Thank you for having me.
Could you please share a bit about your background and how you began your journey with Tinfoil as a
Yeah,
start?
yeah, absolutely. So I did my undergrad in France, and then I came to the US like 7 years ago to do actually grad school. So I did my PhD at MIT, where I worked on computational computing and trusted hardware. So during my PhD, I was lucky to, for instance, do an internship with NVIDIA Research, but also to interact with the Intel labs, also to intern with Microsoft Research, and so on all of these topics, basically like trusted hardware, computational computing, and so coming at the end of the PhD, I was like really excited to start a company, and so I started working with one of my lab mates, Sasha, was like he's our cryptographer, and so we started to think about privacy and like this kind of problem that we wanted to solve. We also met Tanya, who's one of our co-founder, who at the time had just left Cloudflare, where she was working on more like internet level security and protocol, and she was really thinking about AI a lot, and that was like pretty exciting. And so we all started to think about different problems we could start solving. We also met Nate, who's our fourth co-founder, who's a prolific open source contributor. He has worked a lot on Tor and a lot of like other very cool privacy technologies. And we actually didn't really start with that project. At first, we were thinking more cryptographic tools, like we did some MPC stuff and all. And very quickly, we realized that one important things we wanted to do was to bring more privacy to AI. And enclave naturally arise as a very powerful primitive to do that and a great place to start. So that's how we started to work on tinfoil altogether.
Mm-hmm. Interesting. Then, why privacy and AI? Like, what type of problems that you set out to solve?
Yeah, absolutely. So I think AI is very interesting because it works better the more data you give it. And specifically, if you think about it, for instance, take a medical use case or something like that, like a medical assistant, you will get more utility out of an AI system if you actually provide it with very personal data. For instance, your entire medical record might be required in order for you to get the best care out of that system or the best utility. And if you look at enterprise application, it's a bit the same. Like if you want a RAG pipeline that's actually efficient, you probably need to give it a lot of very personal, not personal, but very sensitive or proprietary data. And so you kind of have this new system that actually need more and more data to give you utility back or to like actually be useful to you. And on the other hand, you also have a slight misalignment of incentive that you used to not have with classic SaaS services or things like that, where your data is also very valuable for these providers to be able to train and improve the AI. So it's kind of a bunch of different inflection points that make that we're now at a point where we're shipping sensitive and private data to third party way more than we ever did before. And we thought that was like a very interesting problem to try to tackle and try to address.
Mhm, got it. Um, but AI privacy can be approached in several ways, right? Then, which solutions did you evaluate in the process, and what convinced you that your current tech stack was the right choice?
Yeah, absolutely. So we really think of ourselves as a privacy AI company. Like that's our mission. And we were very happy to use any technology available to us. I think at a high level, like what we wanted to build was a system we could really use AI without thinking of what you were putting in the system. That's the same way today you can connect on internet using any network infrastructure and you don't need to trust it because everything is encrypted end to end using TLS. And we wanted to build a system that made it possible to use any AI infrastructure without having to think like, oh, do I need to sign a contract with that person or this person or that person? And so whatever technical solution make it possible to have this kind of AI system where you can just throw your data at and not think about it was like our target. And so we all have a cryptography background, so we all like looked into MPC, FHO, these kind of things, and these technology are amazing, but the problem is that they're pretty limited in terms of performance. FHE is around 10 to the power, I don't know, 6 or 8 performance overhead still, I don't think so. Enclave just arise naturally as a great fit to accelerate this kind of technology and still get a lot of privacy, way more than the state of the art or like what is currently in deployment, and still get all the utility and all the performance that you would expect from these systems.
I see. So user experience is an important consideration for you.
Yeah, absolutely. We can see already that people want big models. They want models that are like very cutting edge and can process like a large amount of data, and that is difficult with the current like, cryptographic system that exists.
Then could you please walk us through Tinfoil's technical architecture?
Yeah, absolutely. So yeah, so I'll try to stay high level here, and you can cut me if it gets too technical. So um, yeah, tinfoil security is rooted in trusted hardware, as we mentioned several times already. And so the idea is that we're gonna create an inference server inside of a trusted environment or inside of an isolated enclave within the hardware chip. And so that means that even if you control the rest of the server or the rest of the computer, you cannot access the data that is inside of this environment. And when this inference server is created, it's also going to create a TLS key, right? Like so a key to encrypt communication. And that key is ephemeral, created inside of the enclave, and no one can access it, not even us. Then when the client is going to connect to the server, first they're going to use mechanism that are called remote attestation to verify that they're connected to an authentic server that is running code that's protecting their data. And then they're going to obtain that key and encrypt all of their personal data using that specific key that only the enclave has access to. And so that means that the client data is encrypted from the client to inside of the enclave, and not even Tinfoil that has access to the server is able to access it or to observe it. And so it's really this end-to-end confidentiality architecture that we achieve with that design.
End to end here means from your data input to the data output. All this whole process is in the hardware, something like a black box, right?
Yeah, exactly. Or we like to say like closed loop system also, that like nothing comes out. Like you send your input, get your output, and no information is disseminated outside of that closed loop system.
I see. Are there any trust assumptions in this black box?
So I mean, you do trust the hardware, right? That's what you talk about. So you do assume that the hardware is correctly implemented from a so you have a trust assumption on NVIDIA and on Intel. I think here what's important to remember is like what's the state of the art and where we're starting from. So this trust assumption already exists when you use like a normal AI system. And the state of the art right now is that your data is going to be encrypted from the client to the server, but when you get on the server, it gets decrypted and accessible to everyone, right? And so, or at least to the person managing the service. And so here what we're doing is that we're taking this system that's already used in production by like a lot of users and greatly raising the bar for what is the actual security that we're providing. And so we do get rid of a lot of security assumption, like on the cloud provider, on us, but yes, the same security assumption you would have on the hardware specifically are still there.
Cool. And I'm super curious about your experience at NVIDIA.
Yeah.
So how does confidential computing fit into NVIDIA's broader vision and strategy?
Yeah, absolutely. So So I did an interview at NVIDIA. Sorry, I did an internship at NVIDIA Research during my PhD. So I don't have like a special view of like NVIDIA high level strategy on this kind of thing. But I don't know. My take on it would be that it does make sense for NVIDIA to develop technology that makes it possible for more people to use more GPU in more places where previously maybe it would have been um, not the favorite location to process data. And so just being able to have a key turn solution that makes any GPU deployment secure, it, it seems natural to see that that's a great bet for NVIDIA because it just makes the market unlocks in a bunch of different ways where you can have, like you can build trust more easily with different types of deployment that maybe you wouldn't have used before.
Mm-hmm. And NVIDIA's H100 was the first GPU to ship with the built-in confidential computing support, right?
Yeah.
So can you tell us more about it? Like maybe how do the fundamental architectural changes make this possible? And maybe there's something to improve in the future or whatever.
Yeah, absolutely. I can tell you a bit more. And so, yeah, for instance, something interesting that I learned at NVIDIA is that a GPU is not a computer, it's a hardware accelerator. So by definition, this conventional GPU actually need to work with a CPU that's already running an enclave. So really what you do is that you take this CPU enclave and you extend it with GPU capabilities. In terms of pure hardware primitive that you need to add to the GPU to be able to support these things. So as I mentioned earlier, you have this secure environment that's very isolated inside of the chip. And so nothing leaves that environment without being encrypted. So for instance, the memory of the computer is going to be encrypted, and that's also valid for the memory of the GPU. So that's clearly something that you need to add in hardware, like a bunch of accelerators to be able to manage this encryption really fast. So it actually doesn't add any overhead to the computation. And I guess the second category of mechanism that you need to add is everything that makes it possible to perform this remote attestation mechanism that I discussed before. So it's a mechanism that makes it possible to prove the authenticity of the chip you're interacting with. And in the case of the CPU and also like the GPU differently, that it's running correct software that's attested. And so this requires a bunch of little chips that works as a chain of trust to kind of attest the firmware that's running on the GPU. So this also requires some hardware ingredients on top.
Mm-hmm. Got it. And Tinfoil actually emphasizes replacing pinky promise trust with provable security. I'm curious about security here. Like, how do you do to ensure users to verify their data and AI models um, that are secure?
Yeah, absolutely. So when you when the client connect to Tinfoil, they're going to be able to retrieve a proof from the hardware that guarantees that you're connected to a server that's correctly configured and is running code that you can audit, and that is always available and always open source for the community to review and to look at. So the way this thing work is that whenever we publish code, so we have like one clear repository on GitHub that contains our inference code, right? And so every time we publish it, it's actually automatically compiled by GitHub, and then we will derive cryptographic hashes, so measurement of that image, and we're gonna put these measurements on a transparency log. So there's kind of analogies with how internet works in terms of security, but so we have a um, immutable log of all the images that we've all ever published and all the source code that's associated with it. And now to kind of close like to finish explaining the protocol. So when the client connects to the server, we will fetch a proof from the hardware and we'll also fetch the proof from the transparency log, and then we'll check that the two matches. And that gives you the guarantee that the server you're connected to is running the open source code that is audited regularly.
Mm, so the developer or the client can also verify that Tinfoil cannot access their data.
Yeah, it's actually happening on every connection automatically. So when you use the Tinfoil SDK or when you use the Tinfoil chat on our website, you have all the security check and all this cryptographic verification that happen on the fly and automatically. And so, for instance, if you go on our website, tinfoil.sh, and try the chat, like you will see on the side the details of the security proofs that are automatically checked.
Mm. So is it a part of the attestation?
So yeah, maybe I can start by explaining attestation. So
Mhm.
attestation is a very powerful primitive, but it's a bit low level and hard to use as is, which means that the only thing that the hardware is going to give you is a measurement of the software that's running there. And so this measurement is pretty raw. It's a hash of the binary that's loaded in memory. And so every time you will see systems that use computational computing or this kind of technology, you will always have the question of what is the measurement I should compare to? What is the gold standard for this hash that should be running on the hardware? And so that's kind of the part of the story that we fill up at Tinfoil with this architecture, with the transparency log and all of that. And so very, very simply, whenever we publish code, online, it's like always open source and it will be automatically compiled, measured, and published on a transparency log. And so that means that the ground truth for what measurement is expected from the hardware always lives on an immutable ledger that can be accessed by the client to check that the hardware is actually running correctly.
Got it. That's the verifiability, the most one of the most important
Yes,
features of Tinfoil's
absolutely.
service.
Yeah.
Mhm. Got it.
Uh,
Um,
I wanted to ask about how do you explain it to customers? Meaning that I remember Tanya telling me after GTC that there was a lot of excitement around privacy and security. So I'm just like curious how it actually like what does it mean, right? And because like we are talking a lot about selling privacy. How do you demo this kind of stuff? How do you explain it?
Yeah, we show it. I think that's the easiest way to do it. And so we have the chat demo, which is an example of an implementation of Tinfoil in a web browser, and where you can simply interact with the AI, ask a question, and you have the security proof there displayed on the side. And I think that's like very easy to follow, and where you see this very simple step where I get a proof of the hardware, I get a proof from the transparency log, and I verify that they match. And so I think that's the way we usually demo it and the way we usually represent it.
yeah, so I actually talked to many AI builders, and I
Mhm.
found actually privacy or TEE is not a familiar topic to them. So then, how does the developer or the integration experience look like?
So once again, I think there's this idea that computational computing or T is a very powerful primitive, but it's a bit low level and kind of hard to leverage for developers or for people today. And so one of Tinfoil's mission is really to take this very powerful technology and abstract it away to make it very simple for people to integrate. And so if you're a person that just wants to use the chat, you just go on our website and use it. Like it just works out of the box. If you want to integrate Tinfoil in your application, it's actually a single change line of code. So where most of the time when you're going to write an AI application, you're going to interact with your inference service using the OpenAI API, which is the standard to send and receive requests from an LLM. And Tinfoil is compatible with this API. And so that means that, for instance, instead of importing the OpenAI package, you will import the Tinfoil package, and all the security checks, all the cryptography is going to be taken care of automatically in the background. You don't have to think about it. You can just use it and know that it's secure end to end. I think here in terms of usability, you can draw an analogy with TLS, where when you connect to a server, you just see the lock maybe in the URL, or not even. It will just yell at you if it's not secure or if the verification doesn't pass. But it's fully transparent to the user in the background. And the only thing you need to care about is that, okay, it's working, it's connected, it's secure, no one can see the data.
That's cool. Okay. So I also tried out the demo or the
Nice.
MVP. Yeah, and I feel the user experience is quite good. So I didn't feel any differences when using the service compared to other like AI service with no privacy features. Yeah.
Yeah, absolutely. I think the magic here is that most of the security features are actually implemented at the hardware level. And that means no performance overhead because all this encryption, all the mechanism that I talking about are all hardware accelerated and no, so you don't pay the cost for security and performance here.
That's nice.
How do you add a new model? How do you choose which models to support?
Well, right now we just support the models that are the most popular. So DeepSeek, Llama, Mistral, Quen, any model that is like all the models are open sourced and like that we can see our user requesting or using.
Right, like you have the model. We must have the model open source, right, for you to support it. And what does it take to support a model technically?
It doesn't take so. For now, on a hosted version, yeah, what we offer is open source model. What is another interesting property of Tinfoil is that for proprietary model, we can also offer privacy for the model weights. So, for instance, think about someone who has a model that took a lot of time and money to train or to fine tune. They want to deploy it in an environment that's not fully trusted. Like that's also something that Tinfoil naturally provides, where you have strong guarantee that the model weights cannot be extracted from the machine. And to support a model is very simple. So we use open source inference server, the LLM. And so adding new models is pretty straightforward. You just need to set up a new image that once again is like automatically built on GitHub that includes the new model. And then that will like create all the proof to be able to verify end to end that you're connected to the right model with the correct model weights.
I'm curious about who are the first users of tinfoil, or are there any particular industries you are targeting first?
Yeah, absolutely. So I think first there's a lot of individuals who are using the chat or the iPhone app. That's always surprising. I have friends who tell me that they're actually using it daily, and it's interesting because we're very privacy focused, right? So we actually, I mean, that's the whole point. We don't see what people use it for. We don't see the logs of the discussion. So it's always nice to have people telling us what they use it for. But so anything personal or things like that, like people will actually intentionally like go and use Tinfoil to ask like things that I don't feel comfortable asking ChatGPT or Cloud, for instance. In terms of like not personal use but integration, like we have dozens of startups that have implemented us in their product, and so a few categories that we see are very personal AI system. So kind of system where once again, to get the maximum utility, you actually need to connect it to all of your Google Drive, all of your text messages, and like actually really want to give it a lot of personal information for it to be very relevant and to work for you. So that's a niche that we see emerging, and then regulated industries. So healthcare, finance, things like that, where privacy is especially important as other categories that we see.
Mm, that's very interesting because I thought maybe the enterprises they will be more eager or more interested to use this kind of service.
Yeah, absolutely. I think enterprise is definitely also an area where we're seeing interest. I think it just takes a bit more time for the market to be educated and for people to realize like why these things matter. But I think it's interesting because we see more and more events, even in the news, that kind of um, create awareness around this problem, and that's when we see like enterprise people reaching out and things like that. So for instance, a few weeks ago you had the court order from a judge in New York that ordered OpenAI to actually collect and segregate all logs from users and all discussions, and so that's the kind of event in the press that we see like create awareness and creates um, reaction on the enterprise space and other space. And so we think we only need like a few of these events for this awareness to raise and this kind of markets to unlock even more.
Mm. Yeah, that makes sense because enterprises, they're more conservative, and especially you're tackling with their sensitive data, right? So,
There's also something interesting with enterprise because for those who are actually very conservative and really worried about security, the way they used to solve these problems in the past was to do pure on-prem deployment, right? And so to keep all of the data on premise. This is actually becoming a little bit harder with AI because you actually need to deploy gigantic system, especially in hardware, because the CPUs are like pretty beefy and require special cooling system and other thing. And so it we're like with the arrival of AI, we're entering also like a space where it's more and more difficult to actually do full on-prem deployment, where you would have everything running locally. So there's kind of this tension between enterprise that really used to really care about privacy and deploy everything on-prem, and this new like AI trend where everyone wants to jump to where this the previous way to do things security is more and more difficult to do.
mm, got it. Then I can see, so Tinfoil's business model can be like B2C and also B2B because you have the interface yourself and now you also have the solution for the enterprises. What's next on Tinfoil's roadmap? Any upcoming features or improvements that you're particularly excited about?
Yeah, I think we're really excited for very large models to be available on the platform. So computational computing had some interesting limitations, specifically in terms of multi-GPU setup, where until very recently, it was only possible to leverage a single GPU to run a model. And so we've had like big models that require 8 GPUs running for a while, but to get that end-to-end verifiability was actually is like what was challenging and took us like a few weeks to build. And so we're very excited to actually release these big models in the coming days for everyone to be able to use.
Mm, that's very exciting. And also, I'm curious, do you have any plans to expand from just AI inference, the private AI inference, to other areas in AI to combine with privacy?
Yeah, absolutely. There's a lot of other things we're excited to exploring. Fine tuning is one, training is another one. There's a lot of different workloads that are exciting. Inference was especially interesting at first, uh, also for interesting technical reasons or security reasons. Um, Inference has this very nice property that it's completely stateless, and that's a very nice property to have for a workload you're gonna put inside of an enclave, especially if you want to remove the service provider from the trust boundary, because often when you do convolutional computing or enclave deployment, like you always have that problem, or where do I put the private state and who holds the key to that private state? And so if you don't have private state, that problem goes away. And that actually is the case for inference, where everything is transient and you don't have any private states that you need to store anyway. So that's why we started with that workload.
Do you have a solution for? I mean, when I use ChatGPT, for example, so it knows some stuff about me, but I guess that in your system there's no real memory. So is there a solution here?
Yeah, absolutely. So for now, for instance, the way we implement long-term memory is with local storage. So everything stays on your device, and anytime you're gonna send a request, like the data is gonna go with it. And that data is actually like it's not a lot of data, so that works pretty well. And then you can build system that makes it possible to improve performance based on that initial architecture. So I guess the ideal security model is all the data is held locally by the user and only sent to the enclave when necessary. And then you can accelerate it by caching it and encrypt it, for instance, closer to the inference server and just sending the key to decrypt it. But my point is that the trust assumption here are very simple. You know who owns the private data is the user, and that makes a lot of problems very simple that you'll usually encounter with TE, like convolutional computing.
How do you see the landscape of AI and privacy evolving in the near future? Will privacy be default?
I really think so. So going back to the metaphor with TLS, I think right now AI is at a stage where everything is very exciting, everything is very bubbly, and maybe it looks a bit like the early internet of the 90s, which was a little bit the Wild Wild West with everyone exchanging data. And so then when you see more and more security coming in, I think it naturally takes over. Um, as we've so TLS started with very specific use cases that where security was required. So specifically um, e-commerce and online payment. I think for AI, the equivalent will probably be extremely sensitive data or like very regulated industries, and I think that's where it's gonna start. But um, I do expect it to take over and become the standard on, and at least I hope it is like the standard on how we interact with LLM and how we interact with AI model in a private way that, yeah, keeps your data
Mhm.
private.
Okay, so then is hardware or the TE kind of solution enough to become the standard, or do you think we need to maybe incorporate other privacy techniques like maybe ZK, FHE alongside the hardware solution?
Yeah, I think so. At Tinfoil, we really think of ourselves as a private AI company, not a computational computing company or not a TE company. So and we all have cryptographic background, so we're very excited to use these tools when they make sense and when it will make sense. I think there's a lot of room for a hybrid system that you combination of both. Some of these technologies have had advantage on some aspects and disadvantage on others, and so sometimes combination makes a lot of sense. Um, Privacy is a complicated guarantees that you can obtain in many different ways. And when you start doing things like accessing internet, calling tools, or doing things like this, there's probably um, other protocols or other privacy technology that you want to use and layer on top to make the whole system private.
Mhm. Cool. But the AI field moves so quickly. And how do you navigate the competitive landscape and address emerging threats?
Yeah, absolutely. So okay, I guess there's two ways to answer this question. So first, on the pure AI front, like yeah, there's a lot of excitement about AI. There's a lot of work working on AI. From a point of view, any direction AI goes, it actually still will have privacy issues and interesting problems to solve on that front. So if model gets better, it gets better for us. If people start using AI more for more tools, privacy is going to be more of a concern and even more relevant. So in that direction, I feel like we're on the wave, and wherever it goes, we'll take it with us. In terms of people trying to solve the same problem differently or the same way, I think this is such an early stage for this technology that um, any sort of competition is actually extremely beneficial for us. I think the main problem that we face is market education and um, having the word out there that this technology exists, that have interesting properties, like for instance, no performance overhead or this kind of thing. So more people talking about this technology and spreading the word that it it exists is very good for us. And so um, any movement in that area is actually like very beneficial for everyone.
Mm, cool. I hope Tinfoil can create the standard for the industry.
I, I hope to. Yeah.
So, Jules, as a founder, I wanted to ask, how was your experience going through Y Combinator?
Yeah, it's been amazing. It's been extremely we learned a lot and grow a lot as a company. I think it's definitely not called an accelerator for no reason. Uh, it really, I think Y Combinator is extremely good at drilling down on very simple principles that you often very easily forget. And so most of the things that you're gonna have repeated to you or that you're gonna be remembered of are very simple things, but that make a lot of sense and are really helpful not to forget when you start a company. So focus on users, focus on building, and avoid the rest. To give you an example, but so many first principle advice that they are extremely good at reminding you and making sure that you don't get distracted from. And so the experience has been amazing for us. The Yeah, people are incredible. We met like so many fantastic founders in the batch. So definitely, um, yeah, super happy to all that experience.
I guess you made a lot of good friends and also acquire some potential customers.
Yes, definitely.
Nice. Jules, we have one last question for you. It's a routine
Mhm.
question. Please name a project you're bullish about.
Yeah, I think so. For people who are familiar with convolutional computing, the previous technology was called secure enclave and had a slightly different angle where instead of putting an entire convolutional virtual machine inside of a secure environment, you will just put the minimum required code, so just a binary, just the enclave. And there's this project from Intel that's called Grameen, and also sees a lot of work from academia that aims at yeah, like having the more bare operating system that can support any binary with the smallest TCP possible. And they're currently efforts to port that project onto TTX or onto this new primitive for convolutional computing. And I don't know, I'm really excited to kind of see a comeback from this abstraction of secure enclave that runs the minimal amount of code and has the smallest possible TCP footprint.
I guess that's all for today. Jules, thank you so much for joining us today. It was great to learn about the different aspects of Tinfoil. For those interested to learn more, we've added some links in the show notes. Thank you, Jules.
Thank you so much.
Thank you, Omar.
Thank you.